Okay, good afternoon, everyone. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon to try and figure out the future of smarter buildings. We are listed on mondaylive.org in case you are wondering who we are. Just also a point to note that views expressed here are personal, not of any company or organization. Just keep that in mind. And let's make this hour as interactive as possible with questions and comments on the Zoom chat. And if you do want any of the links on the slide deck, that is also available on the homepage of mondaylive.org. So head over there for that. This being November, we've been talking about system of systems. This is our second week, and we have couple more weeks after this. So our agenda today, our normal chit chat, and then we're going to be talking about ontologies and system of systems, how they relate to sort of concepts that have some interaction that could be interesting for us to uncover. But before that, hand it over to Ken. What's going on, Ken?
Thanks, Anto. Lots going on. Very busy over here at Automated Buildings. Pulling together our free education sessions for Chicago. The agenda is online. Speakers are getting confirmed, and it's building daily, so keep checking back. We've added a feature, a flyout feature, so we're going to have each session will kind of go sideways to a special page that we can actually feature and provide information about the speakers. I think that'll be quite useful to let people understand what they might be hearing. The first page is actually completed, and it's on our session on cloud native, which I'm extremely proud of. We basically have 4 players in that area, all of which are our sponsors, and we're going to have them as speakers. So that should be a great session. I'm really looking forward to that. We've been trying to, because of our 25-year history, we're trying to just show you how much content there still is online for automated buildings. And we've been having a lot of fun just poking through, and kind of dawned on me that this program we use to provide a 3D connection and linkage to a lot of our history. I actually started over 10 years ago as a cloud service. It was just invented the year before, so it had only been alive for 11 years, and we had it for 10 years. And it's kind of interesting now that people see it and they say, wow, that's pretty neat. And it's like, yeah, we've been using it for 10 years, and it is a cloud service. So it hadn't really dawned on me until I started working with it. Anyway, so we have that online. We've got several of them, and we've come on, and we're it's just a good way to just have a quick recovery of what kind of resources are on the automated building site. And in addition to that, we dug out one. We thought this would be kind of a fun is the Bachman one, and this was a Control Trends Award. They had a session, and it was the one where they brought hands into the I can't remember what they call it, but all the old folks like myself were all in there, and we brought Hans in. Hans has actually been in the industry longer than myself, which there's few people who can say that. But anyway, it was basically the theme of the Control Trends was superheroes, and both Batman and Batman and Superman were there. So he picked up on the costume, and he became Batman. So kind of a fun little poke there. So anyway, having fun bringing back our history. Hope I'm not boring everybody too much.
So you're telling everybody now that you've actually been a cloud native for over 10 years? Yeah.
Yeah, probably even some of the stuff in the beginning, like if you really go back. I mean, certainly the whole database for automated buildings. The 25 years has been online, has never hiccuped, has never moved servers. It's been on the same server for 25 years. As is the document we did 5 years before automated buildings is still on the same server. So I think that's an interesting concept that we don't kind of see the cloud as permanency, but it is. For me, it's I mean, when I think of the amount of laptops I've gone through and the amount of phones that I've gone through in the 25 years, the constant is the cloud database.
Yeah, interesting thought. Cool. All right, so for my slide, I've actually mentioned this paper before, but since we're talking about system of systems and also talking about the value of system of systems and how to think about it from a business perspective, I thought I'd bring it up and just remind everybody of this. So this is a paper that a couple of IBM guys, economists from IBM, wrote back in 2010. And what they set out to do was to look at try and figure out what system of systems is all about and the impact of the fact that system of systems is not well understood. And the way they did that is they looked at the global GDP of the world back then, which was about $50 trillion at the time. And they did the calculation, they split it up into these 11 industries that's depicted here in these bubbles. And they basically did an analysis of that, doing sort of an analysis of how evolved those industries are, and came up with this calculation that back then we were wasting $4 trillion, which is, let's say, about 10% of GDP, because while it looks like it's system of systems, we're not actually using system of systems thinking to actually organize ourselves in the world. So it's costing us about 10% of our GDP, which is obviously a lot of money. Today, that's about $10 trillion. That's a lot. I'm not sure we've moved that much in 10 years. So if you read this, each system has evolved over time to serve a specific need or want in society. And what I'm trying to do is replace society with buildings, right? So that those words are not actually that different. You know, systems and buildings have evolved over the years, and they all create what the building is, right? But the question is, do they really act as a system of systems in that way? And this sort of maturity thing, they've also got in the paper, they're sort of talking about, you know, the evolution between siloed approach to system of systems approach, and we're probably somewhere in the middle here if we try and do some analysis. But anyway, so this is an interesting paper, and actually speaks to the value of the stuff that we're doing right now. So moving on from that, Jim, hey, Rick, a couple of...
Yeah, the Coalition for Smarter Buildings will be hosting a monthly office hour, as usual, on the first Thursday of each month. It'll be December 7th, this coming up. I was just reflecting on that last slide. I guess we're going from silos of silos to systems of systems. Anyway, I think maybe that's our tagline. But the office hour will be, we'll be talking about the specific things that the coalition is up to relative to, endorsement of the Cloud Native Computing Foundation's Cloud Native principles, the IBB, the Division 2525, and how that helps put a finer point on the master format from CSI, how we're endorsing and going to be demonstrating things like open ADR at AHR, and just generally answering all the questions about what the coalition is up to. So that's going to be office hours. And then
the summit.
Yeah, a lot of what we're doing is leading up to the Smarter Summit that'll be at AHR on the Sunday before AHR, as we did last year. We're looking forward to having more specifics sometime this week or next week on what room. Oh, we got room. When did we get the room? Awesome. So we got the room. We're going to have an agenda, and we're going to have demonstrations and potentially some other surprises that we're going to talk about relative to things that people can participate in during the AHR event.
Okay, thank you. No more links, nothing changed there. Anything else anybody want to bring up before we move on?
Just one thing of note. I noticed in Ukraine there was a power outage, which was actually created by a cyber attack by Russians, but the sandworm. But it's actually an OT type attack, which actually took out the power. So physically going through SCADA systems and PLCs to get at it. So it's it's getting closer to home. This stuff. It's caused quite a lot of problems because they took out the power and then they actually used another system to actually extend the outage as well. So it's getting a little bit closer to what we do when they start going into the SCADA systems and affecting everything.
Was it known that Russia did that, or?
Yeah, it's a group called Sandworms. If you just put in Ukraine power outage, you'll get it up.
Okay. Any other thoughts? Right, let us move on then. So system of systems, ontologies of system of systems. So first, what is an ontology? Just remind ourselves, this is the formal definition of it, a concept of categories in a subject area or domain. I underline that because I think that's important for our conversation. So it's really words and concepts and how we actually think about things in a specific domain or area, their properties and their relationship between them. So this is what it is. And the reason I kind of just sort of framed it like this is that if we think of the system of systems slide, I actually had this from last week. So if you think we're in the building space and this is the system of systems of our industry, right? If we're talking about ontology, what ontology are we talking about? Are we talking about ontology of the whole building, which must include all of the domains that's in the building? Or are we talking about, let's say, just that one dot here, which is the HVAC building automation system, maybe tied with a couple of other adjacent systems? So that was kind of the way I was kind of thinking about this, because ontology is to name something in a very specific domain. Is it part of this, or is it the whole building? In which case, if the building is a hospital, there's probably a whole bunch of ontologies to do with hospitals. Where does that fit in? And if we take it broader afield with all of the other system of systems that we're talking about, then where is the ontology? Is it like 100 ontologies here, or is that one big Uber ontology? I don't think so. So that was kind of I just wanted to sort of set that up. We're going to talk about ontology of system of systems. Which systems are we talking about? Is kind of the way that sort of is intriguing me. So anyway, I'm going to stop and throw it back to the group. So what ontology are we talking about?
Can I go even one further for you? So some of our people just came back from the Smart City conference in Barcelona, and smart cities is another thing that's coming in. So you could even extend one further past the building, right? But I think from the discussions we're talking about in our domain, is that where you're focused on? Is that?
I mean, yes, I think so, because this is our industry, is right here.
Yeah.
Right.
Yeah.
And we don't, I mean, while we observe and we look at the technologies going on, this is really what we need to be focused on.
Right.
I mean, obviously there's some industry standard ones. There's obviously the ones we might bump into are Haystack, Brick Schema, Google's digital buildings, or, the real estate course, things like that. But right now, it seems even in our own industry, we couldn't have picked at least one. We'd have thought after a period of time, like with kind of the adoption of BACnet, you know, as being something that was done that we could have at least set out. But I think, I mean, certainly Haystack kind of had a little bit, and Brickschema had a little bit of earlier days, but why Google needed to go off unless they were just thinking about the wider picture beyond buildings, as Hannah was saying about, you know, bringing in other things in smarter cities.
I think that's
we
part
seem
of,
to have 3 or 4 at the moment.
it's an interesting discussion point for a moment, right, Roger? Because, you know, for the folks on this call who've been here forever and have done this for decades, we've seen these things, they keep coming, right? And part of my perspective on system of systems is that's never going to change, right? In 10 years, it'll be some other protocols or some other thing that's invented. And 5 years after that, in a lot of ways, I see systems as being part of that solution process, right? In that, okay, that's going to happen. So, you know, per Anto's drawing and per Anto's systems, there's a system of BACnet devices over there, and there's a system of Haystack stuff over there. You know, one of the things I think we just need to face up is that's never going to change. Everyone has tried to bring them all together under one protocol, one technology, one platform. You know, even the what would I call it? Even the big data of the data lake type approach was another way of trying to solve that. The data lake guys kind of the data guys came to that same conclusion with the concept of data lakes, right? They ended up coming to the conclusion that I'm never going to make all my databases out there to be the same database. So the way to approach that is to have everybody have their own little database, but when you bring it all together into the data lake, you know, you got to make sure you bring clean data into the data lake. So even them have come to the conclusion that we are never going to solve the protocol wars or the way that things are connected together. I don't think that's ever going to happen. You know,
so you think that we're going to remain with a number of ontologies, so, you know, which kind of ends up, we need an integration tool, you know, for those different ontologies. I mean, I know Brian Turner's on the call, and he's already tried to start something on the called OAP, which is trying to actually bring them all in and send them out as a common interface. But you know, it doesn't surprise me. It's going to be the same as wireless. You know, and other things, there's not going to be perhaps a standard, but it means that there will need to be some sort of integration package or something that will allow you to use all of them when you bump into each one.
Yeah, and I think, you know, I mean, look at the reality of the world. You know, you'd think that the telephone or the mobile phone industry, you know, we haven't, of the hundreds of millions of, you know, opportunities to standardize on that, we ended up with 2. Probably never going to be not more than, you know, we're never going to get away from those 2. You know, we probably might end up having a 3rd and a 4th, you know. And that's kind of where my position is. And one of the things I look at systems is just a realization that a common unified thing is really not going to be it. In fact, Anto's drawing of all the dots interconnected in random ways is probably the real truth of the matter. And therefore, I don't really care that something's running on BACnet or Haystack or, you know, whatever's. And therefore, I look at systems as being a part of that solution.
I think when you look at any ontology, you have to have some kind of premeditated understanding of the use cases or the value proposition. And I think that, you know, if you look at buildings or cities or any of these things discretely, the thing that makes the ontology work is that you understood what you intended to do with the data before you collected it. Now, there are some people that say, well, let's just collect all this data. That was the data lake phase, and we'll use statistical tools to go through it. Most of the problem there is for us is that a lot of the data that was collected in those existing data lakes was not physical world analytics data. It was traditional IT data, you know, based on the English language or some language, and traditional math and traditional ideas that are embedded into different fields like accounting, etc. For us, you know, when BACnet was created and follow on to Haystack, people had to build ontologies around physical data that we collect. Pressures, temperatures, amps, resistance, whatever it might be. And I think that if you're looking at ontologies, looking at system of systems, it fundamentally starts with what are you going to do with the data, which gets you to the why.
But I think also, Jim, is that if each of these ontologies are geared up for different things, let's just argue, and you need them for different things in the building industry, one way or the other. You're going to end up with some sort of integration method, as Anna was saying, because there is no, there's no one. You might say, okay, Haystack's good for HVAC. You might say that, the real estate stuff is good for, the non-OT stuff. Who knows? But it just means that it challenges the whole system of system things as well. Because if we're going to use ontologies, then it means that it becomes more of an integration thing rather than a native connectivity between each of those dots on Anto's drawing.
Agree completely, Roger. However, if you ask yourself the question that if you get into system of systems, these domains are going to overlap, as you said. But historically, the metadata, the ontologies were created around narrower value propositions. So, the question is how do you generalize that? How do you extend them? How do you use them? And understanding, maybe the starting point is understanding that you have ontologies in these different silos now, and learning how to work with them at a system of systems level, understanding, as Anno's point, that they're never going to really converge. I mean, that may be the interesting part.
So one of the sort of the ways that we've been looking at this, the integration part in this sort of the IBB and cloud native context, is asking the questions of what specific use cases exist in a particular project or a particular situation for systems to talk to each other, for systems that have their own ontologies, right, that don't necessarily understand each other's ontologies. When they need to communicate for something, what is that purpose, and can that be normalized, can that be formalized into an ontology of use rather than an ontology of the systems themselves? And I don't know if that tickles anybody's
I think you're starting to get into the difference between integration and interoperability. Right? So I don't know if I would say maybe integration is a stop along the way to interoperability, perhaps. And the things that would make integration a whole lot easier are needed to make interoperability possible, right? And you hit the nail on the head. I think we need to think outside the box. It's not just one building talking to another building, or the traditional use cases, energy studies or things of that nature. I think we need to open our thinking up to use cases that don't exist today. Things that we haven't thought about supplying our data to because historically it wasn't possible, or it wasn't easy or cost effective enough, right? I think once we get to something that is a much more universal ontology or better definition of the data sets out there, we're going to find that we have all kinds of use cases that we didn't think about before.
So I have to agree with that. I think one of the things that I'm actually pleasantly surprised about in the last several years is the maturity of the development of software solutions these days, right? And again, a lot of us have been through the decades worth of, software development phases, and And it was used to be really hard and complex, and you have to describe a lot to everybody. But when you look at a complex application, and I'm going to just go outside the box and use Tesla as the example. When you get into Tesla and their user experience on their dashboard, it's phenomenal, right? I mean, it has depth and breadth and capabilities and ideas and thoughts I'd never have thought about. And then when I look at and talk with my team who build product and solutions today, they ask all these natural questions these days that years ago I would have had to tell them what to do, right? Because from a developer's perspective, their world experience is significantly larger than it used to ever be, and they actually ask deep level questions now of me all day long. Hey, why can't I use this data to go do this thing? I've caught it. And I'll give you a classic example without going into the details. Last week in our company, we had this, we called it an AI Innovate exercise, right? And it was just a hackathon, a 3-day hackathon where we just opened it up to teams, and teams came in, all our developer teams came in with an AI theme. And I sponsored one of the teams and thought, this would be fun and stuff. And then I was sat in on the sessions on the Friday. I was blown away with what these guys created in the space of days, with all the tools that are out there. That, I didn't have to, I gave them kind of a broad vision, but the depth of the stuff that they built in 3 days was phenomenal. So I think my point about all that is I think the expectations of what people can and want to do with it has changed dramatically from simple days that we had 10 years ago. Like I need to get all the temperature sensors and aggregate them together so that I could have a common supply temperature for the air handling unit, controls. Yeah, okay. Well, my guys are asking, what else can we do with that, type of discussions. So there's a lot more maturity in that space and expectations of what people want.
It's when the imagination runs into an obstacle of why can't I get that other piece of data that is fascinating, right? It's like, why can't I see what's happening in that room in terms of occupancy or the status of a light? Because the systems the ontologies don't talk to each other. The systems don't have any kind of interoperability. So the only way to know what's happening in that room is the old-fashioned sneaker net. And by sneaker net, I mean somebody running down to the room and then running back, saying, this is what's happening in the room.
Yeah, in fact, Toby Considine, sorry, Toby, he was just posted a similar thing in the Q&A section, right? And I agree with Toby. And Jim, I still use your analogy of, the thermostat doesn't need to be talking to the human resource database, or the nurse's schedule per se, but knowing the nurse's schedule and knowing the temperatures and all that sort of stuff makes for some interesting use cases that I don't need for them to talk to each other. I just need to know and use that data, which talks a little bit to traces the difference between interoperate and integrate, right?
That's such a nuanced point that you don't actually need the data to actually go between one system to another. You just need some applications just need to be aware of the data and to be able to make decisions.
Yeah, Jim told me that story, I don't know, more than 10 years ago, Jim, when you said, do you need the thermostat to talk to the human resource database? And that was an eye-opener. I've used it ever since.
No, thank you.
Well, you know what? At some stage you might, if people start complaining their performances are not good and the indoor air quality wasn't this, and they put in a complaint to HR, they might want to look back at the data. Who knows?
Right.
So couple of people in the audience are very familiar with this topic. I'm wondering if they want to join us, Brian Turner and Toby Considine. If you can just sort of say yay or nay on the chat, I'll bring you on if you want. Otherwise, we'll continue chatting.
We also have now Mr. Peacock, I notice, from ASTAC.
So this notion that there will be one ontology or there will be one database that I think some people have in their heads, is that notion just totally misplaced? And because I mean, what are your thoughts on that? Is that
I don't think there is such a thing as one database anymore, is there really? I mean, everything gets tableized and broken out and to begin with, even within a singular system. So why would we expect it to be one big giant magic database in the sky? That'd be my
doesn't it depend, Tracy, on where where this data is required? For instance, if you're taking, a building, you're actually saying, okay, fine, we're collecting the data on the HVAC. And at what point down the line does it actually just become a 1 and a 0 because it's a piece of information that other people can pull on, as opposed to a haystack or some other object with all the information? It becomes, it depends on where you are in the whole chain, I would guess.
Well, and it's a matter of ownership too, right? Or hosting. So if I am running my app and I need data from some other applications or other places or whatever it might be, I have two choices. Either I can pull that information on demand and bring it in and use it in my application, or I can download it on a regular basis and make it part of my database, right? So I think when you start getting outside of just a normal building application and you start mixing all these different use cases, who would host the giant database of all of this data, right? Everybody, I think, is going to have their own database and pull in whatever data by whatever method they think best fits their application.
And the term for that is some kind of federated control. So the control is done in a consistent manner. And in a way, that is what system of systems is, right? Because you have these entities that have data that is useful not just for themselves, but for other entities. And they if they're in a situation where they can easily do that, easily use the data securely from other nodes within the building, then we have a system of systems.
I think it's about 2 decades since most enterprises began recognizing that trying to cram everything into an enterprise database in which everybody could have a sign up on whether you could add a new table or new columns in the existing tables or whatever, just paralyzed all development entirely and was almost a death to a corporation to try to actually implement. But you used 2 words interchangeably there, Tracy, which I think is important, which is data and information. You are operating your system on your data because you know what it means. It's already information, but data in your system isn't information to me. It's a bunch of numbers that don't tell me anything. And the ontology is about information, about I like to say about wisdom rather than about knowledge. So you know what things mean, and I think each system is the best judge about what its information means.
Because that's a key point, because each system, given ontology is about a domain, about a system, each system knows what it's all about, but not necessarily what other systems is all about, right? That's the boundary of systems. And that's when system of systems gets assembled.
Yeah, it's not assembling data, it's assembling meanings from the various systems.
Right.
Now, meaning could have, greedy words like use cases, but that's meanings. And I was working with the coalition classification of everyday life a few years back, and they were trying to figure out how to anonymize health data to drive medical decisions. And they realized that they asked someone, have you been going to the gym for 5 weeks? Because then we can begin the next stage of your rehab. They didn't know whether you went to the gym and chatted up the pretty check-in girls that watched ESPN for an hour each day. But someone else said, I don't have time for that. I can't go to the gym. But they run the 7 stories up to their office and down every day religiously. So which one has been doing the rehab properly? And if you're just looking at data points, you can't tell. But the meaning of activity, exerting oneself and other things, definitely the guy who ran the stairs won. And that's an illustration of coalition. The coalition guys were wondering whether they would eventually interact with buildings to make sure they're in optimum conditions for decision making when key enterprise-wide decisions had to be made, in terms of oxygen care, managing people's life cycles and other things. That's a fantasy now, but one could imagine hitting everybody's life cycles just right for the most important decisions. And including the guy who just flew in through 6 time zones to get there. And that to my mind is the world of ontology rather than data. The world of ontology rather versus semantics rather, which is why I personally don't put haystack in ontologies, but instead it's a higher level semantic system of the control points, I would say.
So how does this help us with understanding system of systems, which is really the topic of this month?
I think the real question when you break it down to that point, Anto, comes down to, is systems of systems a thing that exists by itself, or does it spontaneously get created because people want to do it, right? Is it a thing that gets designed? Is there an architect and a designer and who sits down and creates all the system of systems, or does it spring up, to Toby's point, by need?
If you look at the literature and system of systems and the old definitions, was a rebranding of what were called complex systems,
Right?
Just many systems interacting together by definition. So I mean, I think it's there, and a lot of the original use literature on systems of systems actually came out of things like NASA,
Yeah.
where they had to hide the complexity of the oxygen system, had to hide the complexity of 14 other things, but just get useful information exchanged between them. And so that was highly engineered. Not all systems of systems are, I would say most aren't. But I'd say that how architected advances is an orthogonal concept to whether it's a system of systems or not.
And one of the things, as I'm listening to everybody talk, we're kind of referring to a system of systems as a really well-defined system, right? The end product of that. But realistically, in most applications, it's more like I need one piece of information from over there and 10 pieces of data from over there and a little bit more, address information from down there. So, they get kind of cobbled together. It's not necessarily a cohesive system that somebody would recognize from the outside in the same way that I think, at least I've been thinking about, right? It's more of everybody is pulling together their own system of systems by utilizing other data that's out there, other information that's out there within their own use case or application. Kind of forget about that sometimes.
Yeah.
I think that's exactly correct. And one of the things that I think characterizes certain REITs or other real estate owners multiple properties is some of them have a template for making the systems of systems that extract the most meaning for their business and their business value.
Yeah, I obviously now agree 100% with that one, Toby, because that's kind of our focus, right? I mean, to your point, from where my focus is now is exactly that. How do I extract all the information necessary to better run operations, people, et cetera, et cetera. And
you might build 4 different applications for 4 different operations teams.
Yes. Yeah.
One for smart bathrooms and one for rooftop management and so on and so forth, right?
But we do have a focus of, again, making sure that any information data that I've got can be co-shared and can be used by anything else, right? So even though I might be building a smart restroom application, there is information there that could be used by others. So we don't ever build in silos anymore. I can't remember, was it Rick's opening statement? What was it? Silos are silos. Yeah, but that's a really key point. We don't consciously do that anymore. In the past, probably yes.
And there's a difference between, if you can get your mind out of the on-prem bit, it's as soon as you get to the cloud level where all this kind of changes and multi-sites and if it was ever happened, because the people need to think the same way, that companies could share data if in something like in Tracy's world where he's got lots of different restaurants or whatever, if they could share and best practices and things. But it's getting your mind out of that building, because quite honestly, I think that a lot of people are conquered by some way or other of doing the interoperability and the integration on site. It's the moment you leave that confine where we're looking at all that information and how it's available to others who may not be in our world even. They're coming. I'm sure people in space management probably are not that aware of, or optimization, not that aware of everything in HVAC. So even though they're kind of sitting in the domain, it's that bit that once you move outside the building.
You mean
But-
HR doesn't need to know wet bulb temperatures in our HVAC system?
It might be the other way around. We all know that if the room is cold and you begin heating before a class, say, so it's an hour event, it'll be just getting up to temperatures, everyone leaves. You actually, HR maybe should be informing HVAC rather than the other way around, so that HVAC can anticipate the needs.
I was just going to bring up this table. I'm going to bring on Brian Turner as well. This is a table that we put together comparing engineered systems and system of systems when I was at Digital Twin Consortium. And this was quite an aha moment for me anyway, is to just think about these two columns here. And in an engineered system, the composition of the system is predefined. You're specifying it, so you know exactly what you're going to get. In a system of systems, you won't necessarily be predefined. The connections are, so this could be, the second row could be sort of debatable. We can come back to that. The completeness of an engineered system is deterministic. You know when it's going to end, whereas in a system of systems it isn't. And also the construction is different, because the construction in an engineered system is generally by a single entity who is responsible, whereas a system of systems is multiple. And the continuation, in other words, how it gets maintained, engineered system is controlled, whereas system of systems is collaborative in nature. So it's like when I saw this, I kind of, the big aha to me was, yeah, I can see why you can specify this column, this left column, the engineered system, you can specify that, right? But when it comes to specifying a building that is inherently system of systems, you cannot specify these attributes. So that was kind of what I got out of that. And
yeah, I mean, that's kind of what I was talking to earlier, Anto, that I don't think there is such a thing as a architect or designer or someone who has a total overview of a systems or systems solution, right? I don't think those people exist, or don't. Well, I mean, they could exist, but they by nature they don't. Whereas, to your point, an engineered systems is very much driven by some key architect, designer, owner,
Right. So getting back to the integrate or interoperate, if you think about this system of systems being the way it is, then the fact that the systems that make up the systems of systems need to interoperate is really the critical thing here. You don't want them to be integrated through an integration process, because that is more akin to the engineered system approach.
In software engineering, there's another distinction that hasn't quite made it here, and I don't know what the yellow on the left would be, which is the distinction between systems that are orchestrated and choreographed. So orchestration, you all look up the conductor and he's waving his wand and you know when to play each note based upon looking to one guy. Whereas choreography, you have a general plan, but that person stumbled a little bit, so you have to catch them differently. There's the
Like jazz. Like
continuous
jazz.
interaction between systems.
Brian, you have some thoughts on this? See, you're driving.
Yeah. Sorry, I don't have my camera on, but it's just better not to while I'm cruising around. Yeah, I would say the one example that was brought up that I often despise when it comes to what we're trying to do with buildings is the electric car. To me, that's way more as an engineered system where one manufacturer highly engineers the interaction between every single aspect of that vehicle. And even though you can have multiple inputs, both internally as well as externally, there's a predefined response to all of those things. And when you're talking about a building and you're dealing with, dozens of systems, whether it's something like HVAC, which we're all very familiar with, or people counting, or the escalators, or the security system, or whatever it might be, there's just a lot of different inputs, many more than can be in a controlled environment as a single manufacturer designed electric car. And until we get to the point of designing buildings as a single manufacturer, I don't think that's a great comparison. I think it's actually much more complicated to make a building really intelligent in that way. And then my comment around ontologies, and I agree with a lot of what has been said already, but I would say that the thing about a good ontology, regardless of the domain, is that it is broken down to a very common language, common understanding amongst all. You don't have to be a scientist to understand what I'm talking about when I say a wolf just passed in front of me, right? We all know what a shark is, but we don't all know what a HU is, right? If I just say that commonly, even in my office, not everybody's going to understand what I'm talking about. And I would argue even within ASHRAE, you'll get arguments around an MAU, AHU, heat pump. I mean, it's kind of fascinating to me how manufacturers have even chosen different acronyms for the same type of equipment in a lot of ways. And so to me, that's where we really break down, is just having a common understanding, because until we have a common understanding about all this data that we actually have, or the information that we can gain out of that data, there's no way that's going to be highly interoperable amongst other people that don't already also understand our domain. And I think the other key piece of that ontology is the relationships to the other parts. So in the build environment, obviously the relationship to the spaces, to the floors, to the buildings, to the portfolio, to the building type, building class, all of those types of things, I think are really important if we ever intend for these different ontologies to truly interoperate in some application like a Crystal Reports or a Power BI or something like that. You're really going to have a true common understanding around what all of this data is,
including data that's not in your domain.
Absolutely. I don't know that there's a correlation strongly for any kind of animal in our buildings and what the best environmental data is for it. But certainly in certain laboratories and in universities, they certainly want to know that, right? So when you're having a discussion with somebody whose primary focus is labs and animals specifically, you want to be talking about temperature in the same way, humidity in the same way, air handlers in the same way, whatever it happens to be. So I do think there has to be common understanding. Otherwise, it's really difficult to make business decisions when 2 or 3 or 4 people are talking about something with a completely different understanding of what it is.
But is that an understanding of how you're using that data to make it useful to you?
No, I think it's an understanding of what the data is. So every data piece, every piece of equipment, every entity type, they all have an identity. And I think a common, the best ontologies will create that common understanding of what that identity is. And I think we still have a long way to go. And I don't think there will ever be, like someone said earlier, that there will ever be one ontology to dominate them all. It's really important to understand all of them, but it is for each domain, it's really important to have commonality around identities. I mean, even if you just focus on our primary domain with Brick and Haystack and what Ashtray is doing and what Google tried to do, they all pretty much define the same things the same way, but then they start getting nuanced, and even the new Quantum Alliance, it starts to get nuanced, and even those among the same industry don't have the same understanding or same definition for things. And so because of that, it's really hard for people outside the industry or in adjacent industries who want to make use of that information or the data itself. It's really hard to do that in a scalable way. So I think ontology is a critical piece. I don't think they all have to be, I don't think everybody has to have one ontology from, that starts from the universe, but I do think that we have to have a common way to speak about things, both internally that can be consumed externally. If that makes sense.
David, are you wanting to chime in? Go ahead.
I just wanted to ask an open question to this august brain trust, and that is, we've seen all of these things not succeed, and I would like to ask, what will it take to make this interoperability happen? And I know that's a pathetically open question, but I'd love to get some people's thoughts on that, considering what we're striving to do and how we actually get there. What's the next step?
I have a quick and easy answer to that. There has to be a value proposition. I know that sounds incredibly simplified and obvious, but without a financial gain of some sort, either through cost savings or revenue gain, people aren't going to want to do this, as a general statement. And then secondly, I think there needs to be a desire for people who are creating systems to design, define, architect their systems, their platform, their data sets in such a way that they are consumable by others, right? Well-defined, easily understood, readily available as a starting point. And these are just basic, best practices kinds of stuff. It's not a magic solution by any means, but
I would say, David, that in fact we have been fairly successful. I just think that the time constants are very, very long in the industry and for what we've been doing. We wouldn't have an analytics business today if we didn't have BACnet and LAN and other things that standardized the fundamental data definitions for the industry. And Haystack has taken that further. All right, well, it's been a 30-year journey, which most of us have been on. But the fact is that we have liberated a lot of value and we have made great strides. So what's out there for the domains that we've touched, we've come a long way. However, if you look at one of the fundamental problems in the industry is the difference between the construction and operation side of the business. If you look at building information modeling and how that meets the work we've been doing, there's a ginormous gap there. And because of that, we haven't realized a lot of the value that we could have. And, I think that problem will get solved eventually. But I think that the people still operate their businesses in silos. And some people felt that the juice wasn't worth the squeeze for them to make that data available to us. Right? Yeah.
And I'll come at it from a different perspective to yours, Tracy, in that, I think, until people pay for it. But by the same token, we have seen generational changes in technologies. When we went from pneumatics to electronics, nobody ever asked to say, hey, my pneumatics doesn't work. I want electronics. No one in the market said, oh, I need electronic DDC controls. They wouldn't even know what to ask for. The fact that Honeywell did it and created it and put it in front of everyone, everyone go, that's what I was asking for. No one ever said we need building automation systems, you know.
So you're saying that whatever we're going to be using in 5 years, nobody in this industry is asking for right now.
That's kind of where I'm coming from. It's like, you
It's
know,
good. That's
yeah,
horse and car,
horse
right?
in the car scenario, right? I mean, but having said that, I also line up with Jim Lee's time constants. I remember a product management class I was on in my very, very early start into the business. And I went to a big class and it was a whole bunch of product managers from different companies. And the teacher said, okay, there was a company there who made bowling balls and another company who was into nanotechnology at the time. And we were talking about time constants, to Jim's point. And the bowling ball guy goes, yeah, we're decades when we change from a bowling ball technology to a new bowling ball technology. You know, it's not something that changes overnight. And the nanotechnology guy goes, I live in this time scale of hours, you know, so time constants matter in industry.
And a lot of what you've been mentioning there, Anno, is also about what's being developed outside. You know, think about the technology, you know, the microprocessor going through, you know, being available, allowing us to do that stuff from the pneumatics and the other things. And I think, you know, we're going to be dependent upon, obviously, the technology that's around, allowing us to actually build things on it.
Yeah.
So we've come to nearly the end, and I have a question. This should be a no-brainer. I hope it's a no-brainer. But my question, of which yay or nay, or I'm taking the fifth, a la Mark Peacock, thank you very much for the format, is ontologies critical to making system of systems work at scale? Are the two really sort of critical for each other? Do we have to? I'm going to start with I'm going to go around my screen. Tracy?
Yes.
Roger?
Yeah.
Ken?
Yes.
Anno?
No.
Rick?
Take the fifth.
Jim?
Yes.
Toby? That was a yes. David?
Yellow.
Brian?
Yes.
Mark? He's pleading the fifth. And Steve Fay is going on vacation, so he doesn't care.
Probably the most important one then.
Yeah, so that was a pretty easy one. That's a pretty low ball. So it's important, and I think this has been a good conversation today. Thank you, thank you, Toby, and thanks, Brian, for your contribution, and thanks everybody for being here. And I hope everybody has a good week, and we'll reconvene next Monday.
Awesome. See you.
Bye-bye. Bye.
Bye-bye.
Good.
Bye, guys.
Like,